let's make one that is nastier to solve. So you've got a battery, we've got a resistor. Let's say we've got a battery up here, we've got a resistor, we've got another resistor, and finally a fourth resistor. Okay. Let's say this is 12 volts. Let's say this is 8 ohms. Let's say this is 15 volts. Let's say this is 12 ohms. Let's call this R3. Say it's 15 ohms. And let's say here R4 is 18 ohms. All right. So here's our circuit. All right. And again, we can start writing Kirchoff's rules. I1, current flowing through R1 splits off into R2 and R3. So we can say I1 equals I2 plus I3 at this junction. And then at this junction, we can say that I4 also equals I2 plus I3. Alright, if we write a loop rule around this first loop, we've got a voltage increase of E1, then we've got a voltage drop, I1 R1, voltage drop, I3 R3, voltage drop, I4 R4. Okay, going around this loop. We're going backwards through this resistor, so we've got a voltage increase of I3 R3, and we've got a voltage drop across the battery, and we've got a voltage drop across the resistor, though I suspect this I2 will wind up being negative because this is 0. I keep forgetting to put those zeros in here. And then this is also equal to 0. Okay. Now, if you start trying to substitute, the algebra gets really hairy. So what you can do is kind of rearrange this into a square matrix. If we take this first equation, we can say 0 equals minus I1 plus I2 plus I3. Collect all the variables onto one side. Then our second equation, we can say 0 equals, and I'm going to line things up here, I2 plus I3 minus I4. You should be getting flashbacks to pre-calc here when we're solving our systems of equations. This one, if I rearrange this, I can say E1 equals I1 R1 minus I3 R3, plus I4 R4. If I rearrange this one, I can say that E2 equals I2 R2 minus I3 R3. Then if I rewrite this with all of my values in there, I've got with my values for the resistors and the batteries, we get all of, that's a 1, sorry, 2 plus I3 minus I4, then E1 is 12 equals I1 R1, well R1 is 8, so that's 8 I1 plus R3 is 15, 15 I3 plus R4 is 18, plus 18 I4, and E2 is 15 equals, where do we go? There we go. I2 R2 is 12 minus I3 R3, 15 I3. Now, whether you may or may not recall, but we can write this in terms of matrices. What we do is we can write this as a matrix. Just write the coefficients: negative 1, 1, 1, 0 is a 4 by 4, 0, 1, 1, negative 1, 8, 0, 15, 18, 0, 12, minus 15, 0. And punch that in our calculator. Oh. As matrix A. That's our coefficient matrix. And we go matrix edit, A 4 by 4, and type in those values. 1, 1, negative 1, 8, 0, 15, 18, 0, 12, negative 15, 0. Okay. And then matrix B is our solution matrix. 0, 0, 12, 15. That's a 4 by 1 matrix edit. B 4 by 1, 0, 0, 12, 15. And then to solve, just take A inverse times B. And if I punch that in, A inverse times B, it spits out 0.622, etc., 0.901, etc., minus 0.278, and so forth, 0.622, etc. And these are, are I1, I2, I3, and I4, square bracket. Ah! So remember, you can solve these matrices using your calculator, and that's significantly easier than solving them by hand. You can also make a 5 by 4 matrix with all of these values and do the command RREF, which means reduced row echelon form, and that will spit out, then the last column of the result will be these numbers also. And yeah, so these are the solutions. These are the 4 currents that we have found. All right.